Cosmology and the Birth of the Earth from Chapter 1 from the Earth textbook. When we think about the universe, think about two things. There's matter and there's energy in the universe. Understanding the universe will give us a good understanding for the processes inside the Earth and the makeup of the Earth. We'll also look at the solar system and think about this, our sun and the Earth and the rest of the objects in our solar system. The early astronomers looked up at the stars and saw a fixed grid of bright, shiny objects. They didn't know what they were. Overlapping those bright, shiny objects were other objects that seemed to zigzag across that grid of stars. So they thought that the stars were fixed in space, and then these planets, they didn't know they were planets, zigzagged across that grid. It wasn't really clear that the Earth was one of these zigzagging objects. The Earth was thought maybe it was flat. It wasn't really clear that it was round. And it also wasn't obvious that our sun was a star like the shiny objects in the sky. There were two views of the universe, the structure of the universe. One of the models had the Earth at the center. That is a geocentric model. And the other model had the sun at the center of the universe, or a heliocentric model. The heliocentric model then, we had the sun at the center and everything rotating around the sun. That was probably the most popular view up until the Renaissance in the 1400s. The geocentric model was really a model based on religion, that humans and the earth was the center of the universe. Ptolemy, around 100, 150 BC, he was an Egyptian mathematician, and he was able to show through mathematical equations that the earth was the center of the universe. That got proved wrong later, of course, but it was, if you can mathematically prove it, it lasted a while, that thought did. So up until the Renaissance, it was, people either went with the geocentric or the heliocentric model for the universe. During the Renaissance, there were some great thinkers in Europe, and names I'm sure you recognize, like Copernicus, Kepler, Galileo, Newton, and they spawned a new scientific exploration. And one of the ways they were able to do this was the development of telescopes. So Copernicus, he published evidence of the heliocentric model, and still not the right model, but he was able to further along the science. Kepler, he looked at those zigzagging planets and was able to come up with a model of the planets having an elliptical orbit around the sun. Galileo, he was really working with the telescopes and found the moons on Jupiter. The moons that go around Jupiter, not all of them, but some of the moons that go around Jupiter. And Newton began to explain the movements of celestial bodies by pretty much discovering and developing the thoughts of gravity. So they're getting telescopes. The Renaissance comes about. They realize that the Earth and the sun, neither of them are the center of the universe. They realize that our sun is a star, and there are these giant incandescent, basically burning gas bodies. It's also realized that the stars were grouped into galaxies, and there were 100 billion galaxies that we could observe in the universe, and that we were a member of a galaxy. They called it the Milky Way galaxy, and within our galaxy there were over 300 billion of these stars, like our sun, and that we live the Milky Way on an edge of one of the spiral arms. Our solar system is on the edge of one of the Milky Way spiraling arms. So our solar system looks something like this. And the sun makes up most of the mass of the solar system. It's huge. It is roughly spherical. The planets are roughly spherical. Sorry about that. The planets. So they orbit the sun. There's 8 of them. We bumped out Pluto. And the reason is the definition of a planet changed in that it can clear its orbit, meaning that there's nothing in the way. And if there is, it would just assimilate um, that object that was in the orbit. So Pluto doesn't do that. It can't clear its orbit. It can't sweep the orbit and get rid of stuff in the orbit. So, and it's also kind of small, so it's not a planet anymore. So there's 8 of them. The terrestrial planets are the Mercury, Venus, Earth, and Mars. They're small, they're dense, they're rocky, and they're different than the gas giants. Those are really large: Jupiter, Saturn, Uranus, Neptune, and they have a low density. Very much part of them is just gas. So the gaseous giant planets on the outer part of the solar system. Exoplanets are planets found outside our solar system. We study those with the Kepler Space Telescope. There are about 2,000 exoplanets found. Our Milky Way may contain way more than that, maybe 14 billion exoplanets. But we've described and cataloged 2,000 of those planets. We study exoplanets for a variety of reasons: formation of the universe, but also we really want to find life on another planet. So it's fun to study these other planets and think about could they be habitable by life outside of our Earth. There are other smaller objects in the solar system: moons, asteroids, the dwarf planets, and comets. Move my face. Every planet in our solar system has moons except for Mercury and Venus. And it's just a solid object orbiting that planet. We like to study those also. They tell us again about the formation of our solar system and processes that happen not on Earth. Asteroids, we study those. There are rocky asteroids and metallic asteroids. These are, when they come to Earth, those are the meteorites. We study meteorites. They have the components of the early solar system in them. So if we can look at their chemistry and try to figure out their age, we can know about the early chemistry and age of our solar system. They're like the raw materials of our planets. Dwarf planets are the small rocky or icy bodies. They're bigger than asteroids. They're 2,000 kilometers in diameter. Eros is the largest one. Pluto is one of these dwarf planets, but it's slightly smaller than Eros. Comets fly about our solar system. They're beyond Neptune, and they also orbit the sun. Sometimes they get kind of close to the Earth, and we can see them, and they go back out. They have a really elliptical orbit to them. So just to go over that again, there's the 4 terrestrial planets: Mercury, Venus, Earth, and Mars. Between Mars and Jupiter, there's the asteroid belt, and the leftover rocky pieces of the very early solar system. So the rocky planets: Mercury, Venus, Earth, Mars, then the asteroid belt, and then the gaseous giants: Jupiter, Saturn, Uranus, Neptune, and then comets beyond Neptune.